Hi everyone, welcome back to Vibe. In today's lesson, we'll be covering math in the SAT, and this is the last part in this series of 5 videos. The objectives for today are to learn the types of math questions you can find on the SAT and to understand how to tackle these math questions. First, let's go over the timing and the strategy for math. So, as mentioned before, there are 2 modules in math, each 35 minutes long with 22 questions. This timing gives around 90 seconds for each question, and I recommend to spend no more than 70 seconds on each question to guarantee that you can finish. Only check if you have time left over, and don't plan to check from the start, so be confident in your answers as you do them. Skip the questions that you don't know and return at the end to complete them. Complete the early questions quickly, as they are often the easiest. Give yourself time for the more difficult questions later on. So when you're able to at the start, do the questions as quickly as possible. You don't have to spend 70 seconds on them each. Maybe you can do 2 or 3 within 70 seconds. This gives you more time and more flexibility later on. Study method. Again, practice is key. Do a practice test first, and from it, you should get what you can do intuitively, whether it be geometry, probability, algebra, complex numbers, or anything. Part B is what you can do consistently but with some thought. C is what you get wrong sometimes, over a series of practices, maybe 1 or 2 mistakes you'll make in some of the areas of knowledge. And part D is what you get wrong consistently. You'll find that these are the areas where most of your mistakes are made. D and C should be your top priorities. Find review materials for the question types in these categories. And for math, don't put time pressure at first. Understand the material first. Know how to tackle each type of problem. Don't waste time by practicing A, as that is what you already know. And when you see yourself improving topics, consider D and C, start practicing under time conditions and add B to the practice as well. Important question types. Below, we've gathered some important content that is important to learn and revise to score high in SAT math. Some of these contents may not be covered in your high school math classes, at least not yet, so it is good to learn if you want to do well in SAT. We start with vectors and matrices. This isn't usually taught in AP Pre-Cal, so make sure you learn the basics, which involve dot products, angle between vectors, determinants of matrices, inverses of 2 times 2 matrices. Geometry, this involves congruence, angle identities, proving triangles, trig ratios, and conic sections. For probability, you should know how to calculate probabilities using a variety of different things, including tables, Venn diagrams, and tree diagrams, as well as different types of probability, including conditional probability. And for complex numbers, understand that imaginary number I is the square root of -1, and basic complex number operations involving addition, subtraction, multiplication, and division. Let's overview complex numbers. So treat complex numbers as having 2 components, the real component and the imaginary component. The example would be 5 plus 2i, which is a complex number. In this one, 5 is real, while 2i is imaginary. When adding or subtracting these complex numbers, simply just add and subtract the real components and the imaginary components separately. So treat them as 2 separate parts. So if you were to add 2 plus 3i to 4 minus 5i, you would add 2 and 4 together, then find the sum of 3i and -5i, and you should end up with 6 minus 2i, another complex number. When you multiply, treat I as a variable initially, but after you solve it, remember to simplify by substituting -1 for I squared, because I is the square root of -1, and hence you have to simplify. A number's complex conjugate is formed by changing the sign of its imaginary part. So the conjugate of a number like 5 plus 3i would be 5 minus 3i. It's also very interesting about the powers of I, the exponents, because you need to know the pattern it may be tested. The powers of I follow a very specific pattern that is also pretty easy to remember. I to the power of 1, again, is just square root of -1. I squared would be -1, because that is the square of the square root of -1. I to the power of 3 is negative I, and I to the power of 4 is 1. I to the power of 5 goes back to being the square root of -1. So as you can see, the pattern repeats for every 4 powers of I. Knowing this pattern, you can find the value of every single power of I. Dividing complex numbers is more complicated, but it's pretty simple to understand. So when you divide, you first multiply both the numerator and the denominator by the complex conjugate of the denominator. This makes use of the difference in squares formula, which is a plus b times a minus b is equal to a squared plus b squared, to eliminate all of the imaginary numbers in the denominator, because I squared will turn into -1. Then all that's left is to simplify, and you should end up with a regular complex number. The example shown to the right is 3 plus 4i divided by 8 minus 2i. As you can see, you first multiply by the complex conjugate of 8 minus 2i, which is the denominator. That's 8 plus 2i. So you multiply both the numerator and the denominator by 8 plus 2i. Then you find that the denominator turns into 64 minus 4i squared. Since I squared is -1, that is 64 minus 4 times -1, which simplifies to 68. Then you simplify the numerator to 16 plus 38i, and you end up with 4/17 plus 19 over 34i. Next, let's move on to matrices. So think of matrices sort of like data tables, because it's populated in both rows and columns. The main question types of matrices are addition, subtraction, multiplication, finding the determinant, and finding the inverse. For the determinant and inverse, they will not ask you to find it for matrices bigger than 2 times 2, so you only need to know the formulas and strategy for 2 times 2. Adding and subtracting matrices is easy. You simply just add and subtract the values at the corresponding position in the second matrix. This means you can only add and subtract matrices of the same size. Use the first formula on the right for multiplication. Remember, the number of rows in matrix 1 must be the same as the number of columns in matrix 2, and vice versa. For example, the two matrices multiply together. For the first term, for the top left term in the resulting matrix, it's just a times w plus b times y. For the top right, it will be a times x plus b times z. For the bottom left, it will be c times w plus d times y. For the bottom right, it's cx plus dz. Then, to find the determinant of a matrix A, B, C, and D, you would find the value of A times D minus B times C. This is the formula for the determinant of a 2 times 2. To find the inverse of a matrix, there is also a specific formula for that, which is also shown. You take 1 over A times D minus B times C, so 1 over the determinant, multiplied by D, negative B, negative C, A. So it's good to remember these formulas just in case you're asked to find the determinant or the inverse of a matrix. Vectors overview. So when you add vectors, you think of it, visualize it by placing them head to tail and drawing the resulting vector from the start of the first vector to the end of the last vector. When you subtract vectors, you reverse the second vector, you reverse its direction, and then do the same process as adding. So you just flip it head to tail, place it head to tail with the first vector, and then draw a line from start to end. You can also use the component form. So a matrix can be broken down into an x value and a y value. You can add and subtract the x and y value separately and find the resulting matrix that way. You can also find the angle using theta is equal to the inverse tangent of ry over rx, where r is the resultant. This gives you the angle of a matrix given its x and y components. You can also adjust the angle based on the quadrant to get the correct direction. For example, if you know the matrix is in the second quadrant, and after doing inverse tangent, you get an angle in the fourth quadrant, you would add 180 degrees to get it into the second quadrant. So be careful with that. Let's do some math practice. Practice 1. This is about imaginary numbers. Pretty simple question, so pause the video, attempt it for yourself, and then resume. Okay, so the answer is D. Now, let's talk through the steps of how you solve this. Firstly, it involves the exponent of the imaginary number, so you must recognize that I to the power of 2 is -1, and I to the power of 4 is 1. Hence, A and B must be equal in value, but opposite in sign. That means 2 and 3 are correct, but 1 is not correct because A is not equal to the value of B. Hence, D is the correct answer. Question 2, another imaginary number 1, this one relating to multiplication. Take a moment and try this for yourself. Okay, the correct answer is again D. Step by step, we first multiply the complex numbers. We find that it's just equal to AC plus ADI plus BCI plus BDI squared. Again, I squared is -1, so it's just AC plus ADI plus BCI minus BD. The imaginary component ADI plus BCI must be 0 because we know that the product is a real number, so the imaginary component must be non-existent. Hence, AD must equal negative BC to eliminate this term, so the answer is D. Let's try a geometry question next. So again, pause the video and try this for yourself. Okay, so to solve this question, you should use the formulas that were provided as well. You'll find that the answer is actually H. The steps would be to draw the rectangle BCEF and use the midpoint formula, which is shown above, to find that the midpoint is 9, 2, x value of 9 and y value of 2. Then you use the distance formula to find the distance between the origin and 9, 2. You'll find that the distance is the value in h, square root of 85, so the answer would be h. Okay, let's try one more practice question, this time for probability. So hopefully you've attempted it for yourself. The answer is A. Firstly, we use X to represent the number of left-handed female students and Y to represent the number of left-handed male students. You can then use this to set up a system of equations where X plus Y is equal to 18 and 5X plus 9Y is equal to 122 based on the relationships they gave you in the question. You can solve this to get that X is equal to 10 and Y is equal to 8. This way you know that the number of right-handed female students is 5x, which is 50. You will then find the conditional probability, which is 50, the number of right-handed female students, divided by the total number of right-handed students, so 50 divided by 122, which is 0.410. And the answer corresponds to A. Okay, we have reached the end of the video and the end of this SAT tutoring series. Thank you so much for joining us. Remember, if you have any questions, please join the SAT group chat. And if you have any need of resources, visit vikinginitiative.com. Thank you for watching and good luck on SATs.